Hi folks, it's Mr. Oakes. So we're starting a new section which is Pythagorean Theorem. Luckily no problems that you're going to do with this require you to actually spell out Pythagorean Theorem. And there's actually a couple other words in here that it's a good thing you don't have to do a vocabulary test. But basically what a Pythagorean Theorem is this Greek mathematician known as Pythagoras figured out that when you have a right triangle, that the square of the two shorter sides, when you add that together, you get the third side square. So you might be like, okay, what the heck does that mean? So, what's that, Mike? I'm over here. So, what I have here is, here's the formula. A squared plus B squared equals C squared. You are going to run into that in high school all the time. Alright? It's going to be in math class a lot. So you're going to use it next year. You might have it the year after. If you do geometry, you're going to have to use it. In trigonometry, you're going to have that involved. It doesn't go away. Like many of the things I've told you, it doesn't go away. Alright, so once you learn it, it's not like, okay, good, I can put that away, I'm never going to use it again. You're going to use it again because you're still taking math classes. Alright, so what we have here is, here's a right triangle. And basically, whatever the value of this side is, when I square it, which remember is, I'm going to multiply its value by itself. And I add it to whatever this value is squared, it's going to equal this longest side squared. Now, some terminology that you need to know. These two sides here are known as the legs. They're the two shorter sides of the right triangle. And the A and the B, that's interchangeable. I can have this side be B, I could have this side be A. Those two values I could interchange. It doesn't matter. Those two, because I'm adding them, the order doesn't matter. But the longest side, the side that is opposite the right angle, so you see our little box here, that tells us this triangle has a right angle in it, that this is 90 degrees. The side that's opposite that is the longest side of the triangle, and we call that the hypotenuse. The hypotenuse is just a fancy word for the longest side of the right triangle. Hypotenuse. Another word that, thank goodness, you don't have to do vocabulary tests. So the hypotenuse, as I said, is the longest or largest side of the triangle and is across from the right angle. Okay? So anytime you have a triangle, basically what I would do is, wherever that box is, I would draw a little arrow off of the corner, and it's going to point to your hypotenuse all the time. And this side is always C. That longest side is always C. The other two, we can change which one's A, which one's B, but the longest side always has to be our C. Okay, I'm just going to move this over a little bit. Alright, so I'm going to do a few examples with this because it's very important that you understand what is expected when you do a problem that involves Pythagorean Theorem. We're just going to really focus in this video on, we are given a triangle and we're just finding a side. I have this one word problem, but it's not really that big a word problem. So we're going to do a separate video on Pythagorean Theorem word problems next time. So let's take a look at the first example. So example 1, it says find the exact value of x. Now that's important because exact means exactly what it means. It means exact. I'm not going to round. So if I take the square root and I get a decimal, that's an estimation. I can't use that. Basically what happens is I'm either going to get a whole number because I round up with a perfect square so I could take the square root, or if I don't get a perfect square, I'm just going to leave that answer under a square root symbol. Okay, so let's take a look at this one. So find the exact value of x. So if you look, you see here we have this side here is 6 meters, this side here is 8 meters, and the x on that side. Now, you'll also notice I actually have the vertices, the corners of the triangle labeled. So this corner is A, this corner is B, this corner is C. Now, remember, we have our sides here, A, B, C. So I'm going to actually use these to help me. So the side that is across from this angle is going to be A. So I'm going to write, there's A. The side that's across from B, which is where the 6 meters is going to be my lowercase b. So you'll notice, that's a capital A, this is a lowercase a. The angle is a B, the side is a lowercase b. Capital B, lowercase b. And then here, across from the C, well, there's the right angle right there. So that's our hypotenuse. So that's going to be a lowercase c, which pretty much looks to be about the same size as our capital C, but what do you know? Okay? So then what I'm going to do is I'm going to write down the formula. A squared plus B squared equals C squared. And now that I kind of have, here's my A, so A is going to equal to 8 meters, B is going to equal 6 meters. So I'm going to go and plug those in. So A is 8, so I'm going to put 8 squared. B is 6, so I'm going to put 6 squared. And C is going to be x because we don't know what x is. So I'm going to put x squared. Okay? Let's even move this a little closer. Okay. So now we're just going to take this one step at a time. Remember, this 2 that's up there does not mean we're going to multiply 8 by 2. It means I'm going to take 8 and I'm going to multiply itself. So we have 2 8s and they're multiplying. 8 times 8 is 64. We're going to do the same thing with 6 squared. 6 squared means 6 times 6, which is 36. Nothing happening yet with the x squared because we don't know what x is. Now we're just going to add these two together. 64 plus 36 gives us 100. So x squared equals 100. Now what I'm going to do is I'm going to take the square root. So basically what we're asking is, what number times itself gives us 10? So I'm going to put my square root symbol over that and over that. Okay? So, you know, it looks like the old division, kind of division house that you make, but this has a little like overhang kind of thing that tells you it's not the same thing. So then we say, well, what number times itself gives us 100? Well, 10. So our answer here is 10. And since 100 was a perfect square, our answer has no decimal. It's just 10. 10 meters. And that would be our answer. So let's take a look at this next one here. Example 2. This is another way we could use the Pythagorean theorem. It says a triangle has sides 6, 7, and 10. Is it a right triangle? So the first thing I'm going to do is I'm going to write the formula again. A squared plus B squared equals C squared. And what I'm going to do over on the sides, I'm going to write A, B, C. So the first thing I'm going to do when I figure out, well, which letter goes with what number is I'm going to actually look at C, and I'm going to go C has to be the biggest number. So what's the biggest number of the 3 numbers they give us? 10. So that has to be my C. Has to. The other 2, I can put them wherever I want. This could be 6, this could be 7. This could be 6, this could be 7. Doesn't matter. They're interchangeable. So I'm just going to do that. And then we start plugging in. So 6 squared plus 7 squared, and I put a little question mark over that, because does it equal 10 squared. So that question mark kind of tells us, oh, we don't know quite yet if that works. 6 squared. Oh, we actually had it up here. We had it up here. 36. You would think years of doing theater I would know how to cheat out, but no. Here's my back. You like my back? Alright. So 6 squared is 36. We have it up there. 7 squared. 7 times 7. 49. Is that equal to 10 squared? We had that up here too, so we already know, kind of have an idea if this actually works. It's 100. Okay? Add these two together. 36 plus 49 gives us, excuse me, 85. This side was 100. Did we get the same thing on both sides? No, we did not. So, that does not work. So, are these the sides of a right triangle? You would say no. No, these are not the sides of a right triangle. And that would be it. Okay? So, let's go on to 2 more examples. To kind of get an idea. So when you go and you do your work on Delta Math, it's going to give you 2 options on how you can express your answer. It's going to give you an option of, it might ask you to do it to the nearest tenth, or it will ask for the exact answer, the exact value. So I have 2 examples here to help us out. And actually I decided on this one to mix it up, because if you look, we're not looking for the hypotenuse. We have the hypotenuse. We have to figure out what this is here. We have to find out what, well, it's A or it's B. So let's take a look. So find the length of the third side to the nearest tenth. So we're going to be rounding. Okay? Stuff over here. So again, the first thing we're going to do, write the formula. A squared plus B squared equals C squared. Now if you want to, you can label the sides. Okay, you can label them so that it's a little clearer for you. So I know that this side is C because, again, it's the side that's opposite the right triangle, the right angle. The right angle. Is 4 going to be A or is 4 going to be B? Well, over here I have it as A, so I'm going to stay consistent with that, but again, it really doesn't matter. Once we have C, the other 2 sides, the letters are interchangeable. So I'm going to say this is A, and the side that we're looking for is B. So let's plug values in. So A is 4, so 4 squared plus, we don't have anything yet for B, so B squared. C is 9, so 9 squared. 4 squared, 4 times 4 is 16, plus B squared, nothing's happened there yet. Okay, nothing's happened there yet. 9 squared, 9 times 9 is 81. We want to get B squared by itself. So we're going to subtract 16 from both sides. And we do that because it's on the same side as the B squared. It's on the same side as what we want to get by itself. So we've got to move things away from it, starting with that 16. Cross that out because I have certain students who are like, you need to cross that out. So we're going to cross it out. So here we have B squared equals 81 minus 16 is 65. So, just as we did before, we're going to take the square root. So take the square root there, take the square root of 65. So we get B equals, now, you're going to want to go in your calculator, okay, 65. Well, I typed it in. I shouldn't have typed it in first. Second, and then here's my x squared button, and right above it is the square root symbol, so I'm going to hit that. And you see now I have square root 65, and I get this long number, 8.062257748. So I'm going to write that down first. I'm going to step on the sticky part of the last piece. One take. All right, so let's write that down. 8.062257748. Now remember, we want to round to the nearest tenth. The tenths place is right there. But we need to look at the number that's directly after it to tell us what to do. So we have to ask them, does this 6 let the 0 stay as a 0, or does it make it go up? Because 6 is 5 or greater, it's going to make the 0 go up. So we get that b equals 8.1. Alright, so that's how we do that one. This last one, find the exact length of the third side. So we have here 3, 2, nothing. Again, I'm going to label these sides. Draw a little arrow. So that has to be C. So we're looking for the hypotenuse. We're looking for the longest side. Alright, so I'm going to say that's A, and we're going to call this one B. And we're going to write the formula in again. Whoop. A squared plus B squared equals C squared. And then we plug in. So A is 3 squared. B is 2 squared. C is just C, so this is going to be C squared. Now, just as we were doing before, 3 squared is 3 times 3, that's 9. 2 squared is 4, 2 times 2. And again, C squared, I can't do anything with it yet. 9 plus 4 gives us 13. 13 is not a perfect square. So at this point, when I take the square root of both things, there's not much else I can do. It's not asking me to round to the nearest tenth like in example 3. It says the exact length. I can't do anything. So I'm going to leave it like that. C is the square root of 13. And that is the exact length of the third side. Okay? Now, you could always go over to Mr. Cornell's math page if you wanted a little more. He has a couple of videos on Pythagorean Theorem. But I'm hoping that this will hopefully be enough. I mean, you have a number of resources you could go to. There's my page, there's Mr. Cornell's page. I'm willing to bet there's thousands of other math teachers who do this. You could also go to Khan Academy. That's a great site. And there's a number of other sites you could go to. So I hope this helped you. I hope that it gives you a good introduction to Pythagorean Theorem and you can do some of these basic problems. So stay safe, stay healthy. I'll see you soon.